Right. Okay. I have ended the poll and each of you have participated. So let's do the problem. ISI 2015 question number 8. Majority of you have said C. Let us see whether C is the answer or not. So fx is equal to root over x square minus 1 minus log of root over 1 minus x. X is greater than equal to 0. This is what many of you have not seen. Whoever has marked the answer as A and B, you've not seen x is greater than equal to 0. Okay, it's hiding somewhere in the question itself. So root over x square minus 1. So x square minus 1 greater than equal to 0 will happen in two ways. X less than equal to minus 1 or x greater than equal to 1. But since x is greater than equal to 0, x less than equal to minus 1, not possible. So x has to be greater than equal to 1 in order to ensure root over x square minus 1 is defined. Again, root over 1 minus x. So root over 1 minus x log of this. Now log 0 is undefined, therefore 1 minus x has to be strictly positive. That means that x has to be less than 1. So in order for the domain of x, in order to find out the domain of x, in order for the function to be defined, x has to be greater than equal to 1 for the first part and x has to be less than 1 for the second part. How can both of these happen simultaneously? How can x be greater than equal to 1 and be less than 1 at the same time? Not possible. Answer null set. Majority of you have marked this. Absolutely correct. The ones who have failed to mark C, I hope now you have understood why the answer is C. If you have, then please raise your hand. All right. Good. चलो next question में जाते हैं. Next, I will be doing a range question. Okay, so one particular range question, it's there on your screen right now. Question number 11. ISI 2015 question number 11. I am reactivating the poll, relaunching the poll so that you can answer A, B, C, or D for this range question. After this, we'll take a look at a latest DSC question, DSC 2019 question number 1. We'll take a look at that next. Okay, so please take a look at this particular question right now and tell me what is the answer that you're getting. ISI 2015 question number 11. Vote for your answer in the poll. Do it. $25 more seconds. Come on, do it. 20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ending the poll now. Sharing the results. So ISI 2015 question number 11. I need to find out the range for this. There are multiple ways to do this. Absolutely multiple ways to do this. One of the ways is as follows. Look at this: 4 to the power x, 2 to the power x, 4 to the power minus x, 2 to the power minus x, and 3, where x is lying between minus infinity to plus infinity. Okay, so one of the ways to take a look at this is you can see 4 to the power x plus 4 to the power minus x, 2 to the power x plus 2 to the power minus x. So this is of the format a plus 1 by a. This is of the format b plus 1 by b. Okay. Now a plus 1 by a, what can I say? Arithmetic mean greater than equal to geometric mean. This is a very basic inequality that all of us know. Arithmetic mean of a and 1 by a will be this. Geometric mean of a and 1 by a will be 1. So a plus 1 by a will always be greater than equal to 2. Obviously, there is a restriction here that a and 1 by a cannot be negative. See, 4 to the power x and 4 to the power of minus x, these numbers will all be greater than equal to 0. They can never be negative. 1 by 4 to the power x, this kind of a number can never be negative. Understand? Am I clear? So if it is of the format a plus 1 by a, this is of the format b plus 1 by b, both are greater than equal to 2. So fx is greater than equal to 2, greater than equal to 2 plus 3. So overall, can I say that fx will always be greater than equal to 7? I've literally given you the answer now. So basically what you are needed to see is, looking at this expression, there is a format of a plus 1 by a. Now a plus 1 by a is again a format which is very often used in ISI and DSC and maxima minima problems as well. So they will give you a format which looks like a plus 1 by a, and you are supposed to answer or supposed to think about it in this way, that it will always be greater than equal to 2. Okay, and that will come to your rescue. Okay, so if I have the format a plus 1 by a, 4 to the power x plus 4 to the power minus x, how is that a plus 1 by a? Okay, 4 to the power x plus 4 to the power minus x is this. This is a plus 1 by a format. That is what I'm saying. Right? So a plus 1 by a will always be greater than equal to 2. So greater than equal to 2, greater than equal to plus 3. So greater than equal to 7. Answer is D. This is one of the approaches. This is one of the approaches. Okay? Now let's take a look at the other approach. Other approach basically entails us in taking values. Okay? So values लेके आप क्या देखेंगे? Take x is equal to 0. X is equal to 0. 1 plus 1 plus 1 plus 1 plus 3. So f at 0 will be equal to 7. You'll notice that whichever other value that I take, f1, f minus 1, whichever other value that I take, like f1 is 4 plus 1 by 4 plus 2 plus 1 by 2 plus 3. This is obviously greater than 7. Minus 1 will be 1 by 4 plus 4 plus 1 by 2 plus 2 plus 3. It is the same value as 1. F minus 1 will be the same as f1. You'll notice that the lowest value that you will get for the function is when x is equal to 0. The lowest value that you will get for the function is when x is equal to 0. So there will be the range problems where putting in values will also ultimately help you. Putting in values and then seeing the pattern. The pattern is, if I deviate from x is equal to 0, I'll always get a value which is greater than 7. So the lowest value for the function fx is when x is equal to 0 and the value is 7. Okay, answer is D. So you can think about it in any of the two methods, but a plus 1 by a is a concept which I want you to remember, and I wanted to show it to you because there are many problems that we will be solving with the a plus 1 by a approach. Arithmetic mean greater than equal to geometric mean. which will be used extensively, especially when we do maxima and minima. All right, let's take a look at the next range problem. Please take a look at this. Use your entire intellect, common sense in order to solve this. Please make an attempt. I'm activating the poll once more. Polling feature activated. Please vote for your answer. Do it now. I'm ending the poll in 10, 9, 8, 7, 6, 5, 4, 3, 2. Everyone, please answer. Ending the poll now. Thank you for your responses. DSC 2019, question number 1. Range for this function. The way that I'll think about this is as follows. This can be written as x square plus x plus 1 plus 1. So 1 plus 1 by x square plus x plus 1. Okay? Right? Now, let's understand what can be said about this expression. So if I take g is equal to x square plus x plus 1, what will be the maximizing or the minimizing value for this? G dash is 2x plus 1 greater than, 2x plus 1 equal to 0 for a maxima or minima. So x is equal to minus half is equal to 2 positive. That means x is equal to minus half will be a minima. The minimum value for x square plus x plus 1 will come when x is equal to minus half. When x square plus x plus 1 is minimum, 1 by x square plus x plus 1 is maximum. Okay. When this is minimum, when the numerator is minimum, the entire expression will be maximum, because the lower is the numerator, the higher will be the entire number. Okay. I hope that is understandable. That's very basic. So if I put g is equal to minus half here, I'll get 1 by 4 minus half plus 1, which is basically 1 by 4 plus half, which is 3 by 4. So 3 by 4 is the lowest value that x square plus x plus 1 will take. So 1 plus 1 by 3 by 4 basically becomes 4 by 3, which is 7 by 3. So when will this expression achieve its maximizing value? The maxima value for this expression will occur at 7/3. Sorry, the minimum value for x square plus x plus 1 will occur at 3/4, and the maximum value for f will occur at when x is equal to minus half, and the value is 7/3. Now please understand, 1 should have been open interval, ये होना चाहिए था, but this is the best option that you can mark. DSC में बहुत बार you may not get the exact option, so please mark the best answer that is available out of the 4 options. The best answer that is available out of the 4 options is 3. Why is that? Because I know that the maximum value is 7/3. Minimum value x square plus x plus 1 will always be positive. Hamesha, whatever value of x that you take, this expression will always be positive. So 1 by this will always be a positive fraction. X square plus x plus 1, this will always be positive 100% of the time. 100% of the time. You can put in any value and see. So if this is always positive, 1 divided by this is always positive. So this entire expression is always positive. So 1 plus a positive number will obviously be greater than 1. So it should have been open interval 1 to 7/3. But since this is the best option available given to us, please mark this. Answer is 3. ठीक है? I hope I am understandable. If I am, then please raise your hand. थोड़ा तो complex problem तो करेंगे ही, isn't it? All right. Now I hope that you have seen what is a composite function. Composite function is a function of a function. So उसके ऊपर एक question करते हैं. ISI 2017 sample paper, question number 1. Please take a look at this. Put your answer in the poll. I have activated the poll. Please answer in the poll. Do it. This is an example of a composite function. F of gx, g of fx. Function of a function, composite function. Ending the poll in 5, 4, 3, 2, 1 now. चलिए देखते हैं कैसे करते हैं ये कॉम्पोजिट फंक्शन का क्वेश्चन. So function real to real, g real to real, fx is this, gx is this, f of gx will be basically a of gx plus b. Gx is what? Gx is cx plus d plus b. So acx plus ad plus b. G of fx is basically c fx plus d, acx plus bc plus d. So f of gx is equal to g of fx will hold if ad plus b is equal to bc plus d. Now acx is the same, right? So ad plus b, this part should be equal to this part. Now ad plus b is basically f of d, and bc basically c into b plus d. This is basically g of b. So when fb is equal to gb, then fgx is equal to gfx. Answer is C. Very innocent, yet it's not very difficult. Okay, it's not as innocent a question as it looks, but it's not very difficult either. Okay, so should have done this. Right, चलिए ये हो गया. I hope this is okay with everyone. Please raise your hand if this is okay. All right, next question को देखते हैं. सिंपल कॉम्पोजिट फंक्शन हो गया. अब इंक्रीजिंग डिक्रीजिंग फंक्शंस में जाते हैं. ये ISI 2012 क्वेश्चन नंबर 9 को देखिए. An increasing function is one where f dash is greater than equal to 0, and a decreasing function is where f dash is less than equal to 0. ठीक है. बाकी का you must have already seen in the video that I have already shared with you that you were supposed to see. Okay. So now I want you to do this one, ISI 2012 question number 9. Please put your answer in the poll. I have activated the poll. Please देखिए और आंसर करिए. इसके बाद में इनवर्स ऑफ फंक्शन में जाएंगे. Okay, do it. Okay, I'm ending the poll in 5, 4, 3, 2, 1. Ending the poll now. Okay, again, this question is not as innocent as it looks. So ISI 2012 question number 9. F is increasing over this, so f dash is greater than equal to 0. Okay, what can be said about f to the power n? Okay, where n is an odd integer greater than 1. Let g be equal to f to the power n. G dash is n, f to the power n minus 1. Okay, n into f to the power n minus 1. Now, if n is an odd integer, n minus 1 is an even integer. N is an odd integer, n minus 1 is an even integer. Anything to the power of even will always be greater than equal to 0. And n is an odd integer greater than 1. So this entire thing is greater than equal to 0. Am I understandable? Anything to the power of even number will always be positive. So if g is equal to f to the power n, g dash is equal to n into f to the power n minus 1. F to the power n minus 1 is always greater than equal to 0 because n minus 1 is an even number. So n into f to the power n minus 1 will always be greater than equal to 0. That means g is also increasing over the entire range A to B. Answer is A. Those who have marked C, have you understood why C is not the answer? C is not the answer basically because n is an odd number and n minus 1 becomes an even number. Therefore, f to the power n minus 1 will be greater than equal to 0. n into f to the power n minus 1 will be overall greater than equal to 0. ठीक है? Answer is A. सबको समझ में आया, right? समझ में नहीं आया, then please put it in the chat box immediately. If f would have been decreasing, ये देखिए, correct. So f to the power n is this. I've missed this out, into f dash. It's like this, that if g is equal to log of sine x, chain rule है ना? So this will be basically 1 by sine x. Sine x का derivative is cos x. So cos x by sine x. So basically वही मैं कर रहा हूँ, n into f to the power n minus 1 multiplied by f dash. Basically the derivative of this. So f dash is greater than equal to 0 because f is increasing. Correct. Yes, exactly. Yes, exactly. So that was missed out. So f to the power n can be written as n into f to the power n minus 1 multiplied by f dash, basically the derivative of f. So if f would have been decreasing, g also would have been decreasing. Okay. Sad, perfect. चेन रूल, चेन रूल, ठीक है. चलिए अब एक इनवर्स ऑफ अ फंक्शन का क्वेश्चन करते हैं. I hope all of you have seen the inverse of a function video. बहुत सिंपल सा क्वेश्चन करते हैं. If n would have been even, then the answer would have been C. 16. करिए. Put your answer in the poll. I have relaunched the poll. Please put your answer in the poll. Do it right away. बहुत इजी क्वेश्चन है. 30 seconds more. चलो जल्दी करिए, ये बहुत इजी है. I am ending the poll in 5, 4, 3, 2, 1. Ending the poll now. ISI 2010 question number 16. So as I have already shared with you, and if you have seen the video for inverse of a function, ये fx को हम लोग y ले लेंगे 1 by 1 plus x. So 1 plus x is equal to 1 by y. We have to basically write x in terms of y. So this is the functional form of the inverse. Inverse basically क्या कर रहा है? If I am writing y in terms of x, I have to now write x in terms of y. This functional form gives us the inverse of the function. So inverse functional form है 1 minus x by x. Basically, that is what is the answer. ठीक है? Okay. अब होमोजीनियस फंक्शन का क्वेश्चन करते हैं. Let me just open that. DSC 2002 question number 44. As you have already seen, a homothetic function is nothing but a monotonic transformation of a homogeneous function, right? So any monotonic transformation, that is log, exponential, adding a constant, these will all be monotonic transformations. So whenever I have a monotonic transformation of a homogeneous function, it will be homothetic, right? So take a look at this question number 44, put your answer in the poll, do it right away. Tell me what is it that you're getting, do it. Right. Ending the poll in 5, 4, 3, 2, 1. Ending the poll now. Sharing the results. So if you take a look at fxy can be written as log of x square into y cube. Now, if I think about x square into y cube, this is basically homogeneous of degree 5. Basically, what you see is this. Yeah, so lambda to the power 5. So homogeneous of degree 5. G is homogeneous of degree 5. Okay, so that is what we have. So this is homogeneous of degree 5. Log is a monotonic transformation. Therefore homothetic. Okay. Basically, I'll get log of lambda to the power 5 into x square y cube. I'll not get f as homogeneous. F is not homogeneous because I have a log here. Log lambda to the power 5 is not a homogeneous form. It should have been lambda to the power n into log of x square y cube for it to be a homogeneous function. But ऐसा फॉर्म में कभी आ नहीं सकता है. So homothetic है, homogeneous नहीं है. Okay, so I have given you examples for domain, range, homogeneous, simple composite, increasing, decreasing, right? So I have covered all these aspects with you. Now is a good time to go into the other part which I wanted to discuss today, that is convex and concave functions. Okay, before we go into the convex and concave functions, you can take a 5-minute break. Okay, I know that the class has been a little intense, so please take a 5 to 7 minute break. Right now it's 9:03. You can come back at 9:10 p.m. and we'll go into problems of convex and concave. I can leave you with the problem so that you can see the problem and then solve it at your convenience. So let me just give you that. ISI 2019-24. I leave you with that. Okay, so I'm leaving you with this question. Come back at 9:10 p.m. and we'll start. Yes, so the lectures will have a similar structure. Basis the feedback of the students, we might tweak it a little bit, but the idea is that the theory will be done at home and we'll come here and solve these questions together. And I want each and every student to participate. So it will be a problem solving oriented class. Okay, it will be a problem solving oriented class. So please take a look at this. Eco Masters is basically a foundation oriented course. That is the study material for Eco Masters course that we used to have about a year back is the Eco Foundation course. That is the second year's course, not this one. Masters in Economics, this is the course if you want to take it in 2022. 8-week, fast-paced 2022 course. Mock tests are there. You will get access to mock tests in the course itself. Okay. So take a break, come back at 9:10 p.m. and I'm leaving the poll activated for this particular question so that all of you can answer in the poll. When we come back, then we go into solving this. Right. Okay. I hope all of you are back. If you're back, then please raise your hand so that I just have a confirmation that all of you are able to hear me and all of you are back. Okay. Yes, Dev, there will be more sets. Eco Masters is the second year's course. Booster course is the 2022 entrance. Eco Masters that you have taken is the 2023 course. Okay, so that does not include the Eco Booster course. Okay. Right. I'm ending the poll in 5, 4, 3, 2, 1. Ending the poll now. ISI 2019 TA question number 24. Fx is equal to e to the power of x. Now, e to the power of x looks like this. I hope that each of you have looked at the entire theory for convexity, concavity, quasi-convexity, quasi-concavity. Okay, I hope that you remember what is a line, what is the curve, f lambda a plus 1 minus lambda b. This represents the curve, and lambda fa plus 1 minus lambda fb, this represents the line. If the line is above the curve, it is strictly convex, greater than equal to convex. Curve greater than equal to the line, concave. Okay? This is e to the power of x, always increasing. A monotonic, always increasing function, if you have taken a look at my quasi-convexity video, monotonic functions will be both quasi-convex and quasi-concave. E to the power of x is anyway convex, because if I join any 2 points by a straight line, the line is above the curve. So it is convex. Therefore, it is automatically quasi-convex. But it is also quasi-concave, even though it is not concave, right? The reason is it's a monotonic function. Monotonic basically means it's an increasing function. An increasing function will be both quasi-convex and quasi-concave. A decreasing function will also be both quasi-convex and quasi-concave. So an always increasing function or an always decreasing function will be both. Okay. D. All the notes that you just saw are a part of the course. All the notes, all the videos, everything will be provided in the course. Okay. Now let's take a look at the next question. Please take a look at this. This is DSC 2013, question number 22. DSC 2013, question number 22. Please take a look at this. Put your answer in the poll. Okay. This basically looks at the fact that the second order derivative, if it is greater than equal to 0, it is convex. Less than equal to 0, it is concave. Okay. It takes a look at this information. I have given you a huge hint. Now you should be able to solve the problem. Every single one of you should be able to put your answer as A, B, C, D. There should be no sir, please you do now. I've given you a huge hint. Do it. Ending the poll in 5, 4, 3, 2, 1. Now. Okay. This is the function f dash x cube minus 3 by 2 x square minus 6x double dash 3x square minus 3x minus 6. Okay. Now, when will this be greater than equal to 0? And when will this be less than equal to 0? Let's try and understand that. We can write this as x square minus x minus 2. So if I factorize, let's see what I get. So x square minus 2x plus x minus 2. Okay. Okay, this is what I'll get. Now, this will be less than equal to 0 when? Just make the real number line. Minus 1, 2. When x is less than minus 1, both will be negative. Therefore, overall, it will be positive. Between minus 1 and 2, negative. After 2, that is what will be the sign of x minus 2 into x plus 1. Please understand this. Below minus 1, both are negative. Between minus 1 and 2, this is positive, this is negative. After 2, both are positive, right? So less than equal to 0 will mean concave. So between minus 1 and 2, it will be concave. Between minus 1 and 2, it will be concave. And minus infinity to minus 1 and 2 to infinity, it will be convex, because x minus 2 into x plus 1 will be positive. Right? So Bombay is my answer. बहुत easy है. greater than equal to 0 का मतलब है convex. So when will x minus 2 into x plus 1 be greater than equal to 0? When either x is less than minus 1 or greater than 2. ठीक है, आंसर बॉम्बे. समझ में आया ना सबको? समझ में आया? देन प्लीज रेज योर हैंड. यू जस्ट हैव टू चेक द सेकंड ऑर्डर डेरिवेटिव वेदर इट इज पॉजिटिव और नेगेटिव एंड जस्ट आंसर इट. बहुत इजी है. अब नेक्स्ट क्वेश्चन को देखते हैं. ISI 2017 actual paper question number 17. Again a convex concave question. बताइए क्या आंसर आएगा. Do it. Put your answer in the poll. पोल को मैंने लॉन्च कर दिया है. Put your answer in the poll. Do it. Okay, ending the poll in 5, 4, 3, 2, 1. Ending the poll now. Sharing the results. So let's try and understand कि इसका ग्राफ कैसा होगा. सबसे पहले कॉन्वेक्सिटी कॉन्केविटी में सबसे easiest तरीका है if I am able to draw the graph. So f can be written as x divided by minus x when x is negative. ये 1 है when x is equal to 0 and x by x है when x is positive. Basically because mod x is equal to minus x when x is negative and x when x is positive. ठीक है, तो this basically becomes -1, this basically becomes +1. ठीक है, so ये -1 है, ये +1 है, तो कैसा दिखता है? कुछ ऐसा दिखेगा. This is 0 when x is negative, कुछ ऐसा, and when x is positive तब कुछ ऐसा दिखेगा. 0 का वैल्यू यहां पर आ रहा है. 0 is, it's going to 0, not achievable. ठीक है, this is how the curve will be. It will obviously be discontinuous. ऐसा होगा फिर ऐसा. Now join any two points. ठीक है, so if I join any two points by a straight line for this curve, यहां पर the straight line is above the curve, therefore it is not concave here, and yahan par it is not convex because the curve is above the line. Curve is above the line ka matlab hai concave, line is above the curve ka matlab hai convex. So in this part it is not concave, in this part it is not convex, and I have already shared with you earlier in my videos in the theory that if a function is not concave in even one single point in the domain, it is not concave throughout. Similarly, if it is not convex in exactly one point also in the entire domain, it is not convex throughout, right? ये नहीं बोल सकते कि पार्टली कॉन्वेक्स है ना सर, कोई पार्ट में तो कॉन्वेक्स है तब कॉन्वेक्स नहीं. कॉन्वेक्स एंड कॉन्केव आर बाइनरी कॉन्सेप्ट्स. या तो वो पूरे डोमेन में होगा या तो वो कॉन्वेक्स ही नहीं है. Being concave or convex in only one part means it is not convex and it is not concave. तो यहां पर the answer is neither concave nor convex. Majority of you have marked C. Perfect answer है. C is the answer. It is neither concave nor convex because it is concave in one aspect and not concave in the other. Similarly, it is convex sometimes, not convex sometimes. तो आंसर है नॉट कॉन्केव नॉट कॉन्वेक्स दोनों. सो सी इज द आंसर. आई होप दिस इज अंडरस्टैंडेबल. अगर समझ में आया देन प्लीज रेज योर हैंड. Only the line y is equal to -1. Y is equal to -1 is a straight line. It is convex and concave both. But ये y is equal to -1 थोड़ी ना लाइन है. This is y is equal to -1 and discontinuous है. जहां पर 2 आ जाता है वहां पर कॉन्वेक्सिटी एंड कॉन्केविटी नहीं होल्ड करता. ओके, नेक्स्ट क्वेश्चन में जाते हैं. DSC 2007 question number 11. Please vote for your answer in the poll. मैंने एक्टिवेट कर दिया है पोल वापस. प्लीज वोट. क्वेश्चन नंबर 11. Do it. Ending the poll in 5, 4, 3, 2, 1. Ending the poll now. Sharing the results. DSC 2007, question number 11. There is almost a tie between A and C. The answer is both A and C are correct. Okay. No, it's not a trick question. DSC gave marks to everyone who answered this because there are two answers that are correct. So x square, if x is equal to x square, is like this, which is convex. Therefore, it is automatically quasi-convex. Cos x is like this, oscillating. So if it is oscillating like this, it means that it is neither convex nor concave, neither quasi-convex nor quasi-concave. ये तो quasi-convex नहीं है. X to the power of -1. This is also not, because it's basically this. One point when x is equal to 0, fx is equal to 0, and then like this. So it's discontinuous and it is not quasi-convex. E to the power of -x looks like this. Decreasing function, monotonically decreasing function. It is quasi-convex as well. A and C are both correct. Whoever marked A, sahi hai. Whoever marked C, sahi hai. It's a rare thing to see that both answers are correct. Everyone will get marks in such a situation. But A is coming before C, so mark A alphabetically. ठीक है, ऐसे सबको मार्क्स मिलना चाहिए, बट नॉर्मली यू गो ऑप्शन वाइज, लाइक ए को देख लेते हैं, फिर बी को, फिर सी को, फिर डी को. तो ए आंसर आ गया तो ए मार्क कर दीजिए. ओके, whenever you find duplicate answers like this, you should mark it in alphabetical order. Supposing A and D both look to be correct, A को मार्क करिए, D को मत मार्क करिए, but make sure कि both are equally correct. DSC basically tells you mark the best suitable answer. सबसे ज्यादा suitable कौन सा आंसर है उसको मार्क करिए. यहां पर इक्वली suitable है, तो A मार्क करें या C मार्क करें, दोनों में आपको मार्क्स मिलेगा. Yes, so Aparna, I said that a function cannot be convex and concave both. If in one part of the function it is concave, in the other part of the function it is convex. But the DSC question categorically asked you that in which part of the curve is it concave, in which part of the curve is it convex. So if anyone asks you, is the curve convex? If it is not convex in at least one part, you will say that it is not convex. समझ में आया? If it is asking you that in which part it is convex, तो वो तो आपको देना पड़ेगा ना, that in this part it is convex, in this part it is concave. But what can be said about the entire curve as a whole? Entire curve as a whole, if I have to say that the entire curve as a whole is convex, it has to be convex throughout the domain, not in only one part. Okay, चलिए नेक्स्ट क्वेश्चन देखते हैं. दिस क्वेश्चन इज अ पर्टिकुलर टाइप. तो ये पर्टिकुलर टाइप ऑफ क्वेश्चन को एक पर्टिकुलर तरीके से सॉल्व करते हैं. तो क्वेश्चन नंबर 3 and 4 को देखेंगे. इट्स ऑन योर स्क्रीन राइट नाउ. क्वेश्चन नंबर 3 पहले देखेंगे, 4 तो बहुत इजी है. क्वेश्चन नंबर 3 देखिए एंड गिव इट योर बेस्ट शॉट. ISI 2017 actual paper question number 3. This is a two variable case. टू वेरिएबल केस में कॉन्वेक्स, कॉन्केव, क्वाजी कॉन्वेक्स, क्वाजी कॉन्केव को डेफिनेशन से देखेंगे. गो इनटू द डेफिनेशन. डेफिनेशन का वीडियोस आपने देखा है. तो दिस इज बेसिकली द कंडीशन फॉर कॉन्वेक्स This greater than equal to this is the condition for concave. This less than equal to max of FAFB is the condition for quasi-convex. Greater than equal to min of FAFB is the condition for quasi-concave. ठीक है, ये conditions के videos आप already देख चुके हैं. That is what I have shared with you before the class. तो ये definition से जाइए, इसको ग्राफ नहीं कर पाएंगे आप. This will be a 3D figure. Graphing a 3D figure and then commenting about it will be very difficult. So in this case, what you need to do is you need to put in these definitions and then somehow talk about concave, quasi-concave, convex, quasi-convex. ठीक है, तो make an attempt at this and put your answer in the poll. मैंने poll को activate कर दिया है, कोशिश करिए, आंसर करिए. ठीक है, do it. चलिए कोशिश करते हैं. आई हैव गिवन यू इनफ टाइम टू थिंक अबाउट दिस एंड टू डू इट. आई एम एंडिंग द पोल in 5, 4, 3, 2, 1. Ending the poll now. So whenever you're faced with a two variable case and to talk about convex, concave, quasi-convex, quasi-concave, we'll take two examples. Okay, one example which I call is the extreme example. So yes, Dave, we'll have to take a look at that ultimately. Okay, so basically x into y. ठीक है, पहले एक्सट्रीम एग्जाम्पल को कंसिडर करेंगे. 1 1 f11 का क्या वैल्यू है? 1. f33 का क्या वैल्यू है? 3 into 3 9. एंड लेट लैम्डा बी इज इक्वल टू हाफ. तो f of 11 plus 33 by 2, this will basically be representing the curve. Okay, and line को क्या represent करेगा? line को represent करेगा ये. ठीक है, so this will be f of 1 plus 3 is 4, 4 by 2 2, 4 by 2 2, 2 2 will be 4. so curve का value is 4. ठीक है, इसका क्या वैल्यू होगा? 1 by 2 plus 9 by 2, 10 by 2, which is 5. so this is representing the line. line का वैल्यू is greater than the curve. line का वैल्यू है 5, curve का वैल्यू है 4. line greater than the curve मतलब कि ये concave नहीं है. I am only taking out the possibilities. ठीक है, so if it is not concave in one point, it is not concave throughout. तो concave नहीं है. एग्जाम्पल लेके, दिस इज द एग्जाम्पल. सो कॉन्केव नहीं है मतलब बी एंड ए आंसर नहीं है. ठीक है, फिर उसके बाद में आई विल टेक इक्वल वैल्यूज का एग्जाम्पल. अब इक्वल वैल्यूज का क्या एग्जाम्पल होगा? 2,4 and 4,2 both take the same value. 4 into 2 8, 2 into 4 8. ठीक है, and let's take again lambda is equal to half. तो f of 2 4 plus 4 2 by 2, that's basically f of 3 3, which is equal to 9. ठीक है, and minima of f42 f24 is the same as maxima, क्योंकि दोनों का वैल्यू तो सेम है ना अल्टीमेटली, दोनों का वैल्यू 8 है. ठीक है, सो मिनिमा और मैक्सिमा दोनों का वैल्यू जो है वो 9 से कम है. सो दिस इज ग्रेटर देन मिनिमा, ग्रेटर देन मैक्सिमा, बोथ. तो इफ इट इज ग्रेटर देन मैक्सिमा तो क्वाजी कॉन्वेक्स नहीं है, क्वाजी कॉन्वेक्स नहीं है. राइट, obviously I told you that please take in the mathematical definitions. इसको ग्राफ करके नहीं कर सकते, तो एग्जांपल्स को लेंगे एंड एक एक करके लेस करते जाएंगे ऑप्शंस को. कॉन्केव नहीं है, आया ये वाले एग्जांपल से. क्वाजी कॉन्वेक्स नहीं आया ये वाले एग्जांपल से. लाइन का क्या वैल्यू है? लाइन का वैल्यू भी यही आएगा, f42 plus f24 by 2, which will again be 8. तो this is the curve. Curve is greater than the line here in this case. तो convex भी नहीं है. So this particular curve x into y is not quasi convex, not concave, not convex. ओके, खाली एक चीज जो I was not able to eliminate वो है quasi concave. Answer will be that. जो मुझे एलिमिनेट करना है ये दो ऑप्शन से मैं एलिमिनेट उसको कर लूंगा. So the function is quasi concave, but it is not concave. This is my answer. Again, एक एक्सट्रीम एग्जांपल लूंगा, उसमें से एक ऑप्शन आइदर कॉनकेव और कॉन्वेक्स दोनों में से एक को एलिमिनेट करूंगा. Then I'll take an equal example. This will help me in eliminating quasi-convex और quasi-concave. यहां पर quasi-convex eliminate हो जाता है, convex eliminate हो जाता है, concave eliminate मैं already कर चुका हूं, तो quasi-concave बचा ऑप्शन, वही आंसर है. ठीक है. This is the mathematical way of doing it. I can also compare this with an economic standpoint. Economics के standpoint में this kind of a utility function is called a Cobb-Douglas utility function. And if you would have studied consumer behavior utility functions, you would know that Cobb-Douglas utility function yields indifference curves which are convex to the origin. And convex indifference curves only comes from quasi-concave utility functions. In fact, इसका proof भी आप मेरे माइक्रो इकोनॉमिक्स इको टॉपर वाले सब्जेक्ट में you will be able to see a video wherein I have actually proved quasi-concave utility functions yields convex indifference curves. So whenever I have convex indifference curves, I will have a quasi-concave utility function. ये मैंने prove भी किया है in micro economics. Okay. So if you want to take a look at this particular question from an economic standpoint, u is equal to x into y is a Cobb-Douglas utility function. Indifference curves are convex. Therefore, the utility function in itself has to be quasi-concave. तो ये एंगल से भी आप ये क्वेश्चन को सॉल्व कर सकते हैं. द चॉइस इज अप टू यू. मैथमेटिकल एस्पेक्ट भी मैंने आपको दिखा दिया है, एंड इकोनॉमिक्स का एस्पेक्ट, this is the economics aspect in order to understand the same question. So that gives me the answer as quasi-concave but not concave. Majority of you have marked that as the answer. Perfect. बहुत अच्छे. And question number 4 is another part of this question. ये homogeneity का question है. F lambda x lambda y will be basically lambda x into lambda y, lambda square x into y, therefore homogeneous of degree 2. यही आंसर है. ठीक है. Can I have a thumbs up? सबको समझ में आया? Then please give me either a thumbs up or raise your hand. Both these questions understood? Please raise your hand. तो आज के क्लास में हमने क्या क्या किया? आज के क्लास में सबसे पहले we took a look at functions domain question, then we took a look at range question, फिर हमने देखा increasing decreasing, हमने देखा simple composite, inverse of a function, homogeneous function, convex concavity के special cases देखे, one variable cases देखे, and right now we saw a two variable case for a convex, concave, quasi-convex, quasi-concave function. ठीक है. So this was my aim to show you one particular question for each type, which is important for these entrances, and we'll follow a similar pattern for the other topics. Like for example, when I teach you limits, I will be sharing how to do a question by L'Hopital. I will be sharing with you how to do a question with series expansion. I will be sharing with you how to do a question by taking a logarithm, right? तीन चार जो different methods है of solving a limit question, I will be showing you each and every type. Okay, so that is what we will be doing for each topic, showing you one particular type for each topic. The remaining questions that are left in the sheet, you are expected to take a look at the solution videos. Okay, so obviously we are not solving the entire sheet. Entire sheet में आपको काफी सारे questions मिलेंगे. जैसे this is the sheet for only convex concave. इसमें से I have done a very small part. Okay, बाकी के जितने questions है, I will expect you to do them on your own and see the solutions that are already available on the student portal. ये सारे questions के solutions are already available on the portal, right? तो जितने questions मैंने नहीं कराए हैं क्लास में, वो सारे questions को खुद से try करिए. You will be able to download all the question papers from my website, from our website edusure.in. So वहां से download करिए सारे papers को and take a look at each and every problem on your own, solve करिए खुद से, उसके बाद में solution videos देख लीजिए. ठीक है? This has to be the modus operandi for every topic. मैं सारे क्वेश्चंस क्लास में नहीं कराऊंगा, मैं कोई कोई पर्टिकुलर टाइप को क्लास में कराऊंगा. उसके बाद में जितने क्वेश्चंस आपके बचे हुए रह जाते हैं वो आपको खुद से करना है एंड सी द सॉल्यूशंस. ओके, काम करते रहिए, आयुषी कॉन्फिडेंस अपने आप आ जाएगा. ओके, इट्स ओनली बिकॉज इट इज अर्ली डेज. हमेशा अर्ली और द बिगिनिंग ऑफ अ सेशन में कॉन्फिडेंस नहीं रहता है. as and when you start solving, as and when you get into the groove, confidence अपने आप आ जाएगा. ठीक है? Right. I hope that each of you enjoyed the class as much as I did, because I certainly did enjoy it. I wish to see each of you in the next class. Be well, stay safe. If you need any more information about the booster course, please contact our admissions team. They will give you all the information. 8100480050. If Nitesh sir is not available, you can also contact Khushbu ma'am at 98313-27247. Okay, you can contact on any of these two numbers for the admissions. They will be able to guide you on the entire course much better than even what I will be able to guide you. I focus on the teaching part, they focus on what are the features of the course, so they'll be able to guide you in a better fashion. Okay, for Friday, the topic will be game theory and SKM. Normal class and optional class, I'm not aware. What are you asking? Aparna, each and every, whatever questions that I've done today also, their solution videos are also available, right? So I don't know what you mean by the question. You can ask the admissions team if they have mentioned something to you. Please speak with the admissions team. I think they will be able to clarify it better, what they mean by that. Okay, right. Thank you so much, everyone. Be well, stay safe. See you in the next class very, very soon on Friday. Bye-bye and good night.